Alright, in this video, I'm gonna share to you how to work on these questions. These questions is taken from AS level paper. Alright, it's actually from 9701. Alright, so M19 and it's actually QP22. Alright, so I love to discuss February March paper because this paper according to the survey that I got from the many of students, this paper is a bit tough or tougher than another series, but it is only like hypothesis, all right? So it can be true, or at the end of the day, you may refute the fact, all right? So um, now we have PQ and R. We have a P we have a functional group. So we have cyanide functional group. You have also hydroxyl functional group. In Q, you have a ketone functional group. And R is basically is actually what do you call this one as a aldehyde functional groups, right? And then you also have a alkene, all right, which is the unsaturated hydrocarbon. Now, in order to overcome these questions, you should very clear on your understanding whether a specific reagent, all right, in this case we have, in these questions we have sodium, we have also, we call this one as a 2.4 DNPH, and we also have acidified K2CR2O7, right? And then these three reagents will be we will attempt to add each of these reagent to solution to the molecule of PU, Q, and R. All right, PU, P, Q, and R. So basically, the questions is asking your understanding whether this reagent is reactive or not react with the P, Q, and R. All right. Now, it is if you look at the questions, the first row is basically a reaction between sodium and P, Q, and R. So in this first one, all right, so sodium reacts with P, it is absolutely react, yeah, because P has a OH functional group. And as you know, when we have the O and H, all right, so this is actually negative charge, negative dipole, and it's actually plus dipole, and then of course the bond pair of electron between O and H goes to oxygen. Therefore, you would have negative, and of course, this negative will attracted to Na plus, right? So the reagent of Na. So definitely, when this hydrogen is expelled out from the OH functional group, then it will give you hydrogen gas. All right. So that's why P reacts with Na will give you this. All right, or effervescence. Effervescence. All right. Okay, so that's actually the first reaction. What about Na with Q? All right, Na with Q. Definitely, because we have a ketone functional group and there's no OH functional group, so the answer is no reaction. All right, and of course, as well as R, because we already identified that R has a what do you call this one, aldehyde functional group, so aldehyde will not react, yeah, so will not react with Na. So for the conclusion is Na reacts with, so you can actually note of this one, yeah, so Na reacts with OH or COOH. All right, so both of this one in short will give you hydrogen gas. All right, but then I need to disclaim, all right, not all this product will give you hydrogen gas, so there will be specific reagent will not be react with sodium or with metal. All right, next is we have 2.4 DNPH, right? So if we react this one 2.4 DNPH with P, definitely it give you no reaction. Why? Because 2.4 the NPH is specifically will give you reactions when we have the uh, ketone. All right, so this one is actually ketone, and then also what it goes one as a um, carbonyl functional group. All right, so this is actually carbonyl. All right, so there's also carbonyl. All right, so carbonyl is actually CO. All right, so the carbonyl functional group can be in the form of ketone and also can be in the form of aldehyde. All right, so we have this COH over here. I would like to highlight to you, if it's written CHO, then you read this one as aldehyde, yeah. So if it says COH, then this actually alcohol. It is kind of popular in the paper that you need to be very aware on the specific nomenclature, right? So that's actually the thing that you need to remember. So since these two, yeah, so since P has no carbonyl functional group, so therefore P gives no reaction, while Q and R, the observation is always give you the orange PPT. All right, so you would have orange PPT. All right, both P and R give you orange PPT. Okay, so next is the other thing that you need to remember. All right, so acidified K2Cr2O7. So when you heard this one, Cr2O7, meaning that this substance it will, because it has more number of oxygen, so definitely this one can donate electron, right? So it will donate the electron, so it's like that. So meaning that there will be like reaction. So if you react some uh, acidified K2Cr2O7 with molecule, then it will give you uh, another oxygen. All right. So in this case, it is impossible for us to add more oxygen because in this case, there's no more bond that we can actually oxidize. All right. So unlike here in R, so we still have this one. All right. CHO. COH. So definitely when we have this H, then we can actually attach the O. So the reaction, the product will be COOH. All right. Unlike here, because the presence of double bond and we have no more hands of carbon. Look at this one. The number of the hands of carbon is already 4. 1, 2, 3, and 4. So no more there's no more hydrogen. If there's no hydrogen, so you can actually oxidize it one. All right. So remember that oxidation is replacements of oxygen, replacements of hydrogen by oxygen. So we exchange hydrogen with oxygen. All right. So therefore, for Q is actually no reaction because in this case you don't have anything to thread in, but then in R you have COH. So definitely I can write here no reaction, but R will give you green. Yeah, so it turns green. All right, why green? Because this one, okay, I invite you to remember that K2Cr2O7 is acting as oxidizing agent. So oxidizing agent meaning itself undergoes reduction. So the reduction is basically in the form of Cr2O7 2 minus goes to Cr2 plus. All right. So of course the oxygen state here of Cr is actually plus 6. All right. So it's from 2x minus 14 equal to minus 2 because the oxygen state of oxygen is actually minus 2. Why minus 2? Because oxygen is located in group 6. Remember the charge or oxidation number or oxygen state is the same as their group. Yeah. So Sorry, just right here, group. So it's much more clear. Group number. All right. So uh, if you are still confused, all right. So I'll tell you the secret. So group one will have plus one charge. Group two plus two charge. Group three will be Group 3 will be plus 3 charge. Group 5, Group 7, 6 and 7. Alright. Group 5 minus 3 charge. Group 6 minus 2 and Group 7 minus 1. Why do we have this minus? Because 5 needs, okay, imagine 5 needs 3 more electrons to be 8. Alright, so therefore 5 group all elements or all atoms in group 5 requires 3 more electrons to be 8 or to be 18, right, as a noble gas electronic configuration. And when they accept or when they gain electronic or 3 electrons, all right, so they will be stable. So 6, it lacks 2 more, so that's why it has a negative 2 charge. And then group 7 lacks 1 more, so meaning you have a minus 1 charge. Same thing here. If you have a plus 1, then you in order to be live in order to be stable, then they need to remove or lose 1 electron and also 3 electrons, right? So in this case, Cr2O7 2 minus is actually plus 6 and is actually plus 2. Then the Cr2O7 loses its oxygen, so therefore the oxygen state is changing from plus 6 to plus 2. So it turns green. All right, so the greenness is coming from the presence of Cr2 plus. All right. Okay, so now I already done this one. Okay, so um, now if we continue, Q is reduced by NaBH4. Okay, so I want you to remember that NaBH4 is actually the example of reducing agent. All right, so it's actually the opposite of Cr2O7. If you ask me, can you give me another example of reducing agent? So I will submit to you this one, IALH4 and NaBH4. So this is actually the most common reducing agent, right? So reducing agent means that itself undergoes oxidation. Okay, all right, so it's actually like vice versa on the thing that we have discussed previously. All right, so now if you ask me further, which one is stronger, Li or Na? So I would say LiAlH4 is actually stronger than NaBH4. For more information regarding this, I'm gonna prepare another video how to identify which one is more stronger and which one is more or less stronger in terms of reducing agent. All right. So write an equations for the reactions between Q with NaBH4. In your answer, use H to represent in ABH4. So you can actually write C5H10O plus 2H. All right, and then it will give you C5H12O. Notice here, because we introduced 2 hydrogen, so you would have additional 2 hydrogen on the right hand side. So why? Because and in this case, an ABH4 is actually a reducing agent, so it donates hydrogen. Okay, donating this right here, donating hydrogen. All right, so when you have this one, then the previous reagent will accept 2 electrons, then it will give you C5H12 and O. All right. Okay, so let's continue. R exists as a pair of stereoisomers. Identify the types of stereoisomers shown by R and draw the structures of the other stereoisomers. All right, so definitely the stereoisomers is basically whether you have a cis and trans. All right, so when you heard stereoisomer, you um, need to remember that this isomer occupies cis and trans structure. So trans meaning that you would have the same what equals 1, the same structure, all right, the same atom on the same side, and like this. And then cis is basically it happens in also in CC double bond, so like this one. All right, so the positions of Cl is on the opposite side. All right, so this one is actually cis and the other one is actually trans. All right. Okay, so having said that, because it says that R exists as a stereoisomer, so what's R? You can actually move up. So R is basically this one. All right, so this is actually the trans. Why trans? Because the positions of H, the one that is actually the same on this molecule, uh, are on the opposite side. So this hydrogen is on the top, while this hydrogen is at the bottom. All right, so you can actually rotate this one. All right, so by writing here. Okay, so let me just scroll down. Okay, so the type of stereoisomer we can actually here say geometrical isomerism. All right, so then you can actually write OHC, C double bond C, and then you would have C2H5, and then you have H, and the other one is H. So C2H5 is basically CH2, CH3. So I just make it short. All right. Okay, so next, it's quite interesting. Many students struggling with this FTIR structure, right? So it says the infrared spectrum shows corresponds to one of P, Q, and R. So we have this structure, all right? So, and the use with the compounds P, Q, and R or R producing this spectrum. Explain your reasoning, right? So in your answer, identify any relevant absorptions in the infrared spectrum and the bonds that corresponds to these absorptions in the regions above 1500 cm-1. All right, so if you look at this FTIR, all right, so I'm gonna prepare for another video regarding how we can actually identify or how the FTIR works. All right, but for the meantime, I'll share to you that the thing that you need to do is always put your particular one, put your ruler, all right, on the 1600. So like say this is actually 1500, 16, 17, 18, 19. So so this actually 16, all right, and then you have also here 16, the green one is basically, and of course this is actually 17. All right, so I always pay my attention on the 1600. So this one. Okay, so once I got this, then my attention will check what is the spectrum that I have here in this region. So it's actually around uh, 21 or 23,000. All right, so what is this and what is this as well? All right, so I need to check with the um, data booklet that given by the examiner or the invigilator on your exam room, right? Now, you may ask me, why do I need to focus on these three spectrums on the right hand side? Because basically, this one will give you specific functional group, all right? So either it's actually OH or C double bond O, or you might have the ethyl and so forth, right? So this possibility you can actually check on your data booklet. All right, so data booklet, please check that one. Okay, now I don't really care, no, actually I'm not saying that one. I don't really focus on this region. So this region is called as a fingerprint region, so I'll just type here. So it's actually fingerprint region. All right, so fingerprint region. So because this fingerprint region is basically will give you so many overlapping functional group that we don't really significant is which is not really significant with our structure. So meaning having said the having said that, so we can actually check what are the what are the functional group that located in this wave number. All right. So, and then later on we will check with the spectrum. Now, if we check again here, all right. So I'll just use the this one first. All right. So when I check in my data booklet, this is like um, the functional group that may have in here, because we have a strong, look at this one, very strong, and but then it's actually sharp. So that's actually how we identify the structure. All right, so this basically strong, and because it's actually sharp, so just put here sharp, so meaning it might coming from the absorption. All right, so the absorptions of the CN, all right, or C or something else, right? And of course, and then this one, all right, so here we have also around here the 3000, and then we also have here, and then this actually kind of stretch, like you are stretching your body. All right, so this one most likely coming from the absorption of the OH. All right, so I would deduce that it is actually substance between PQ and R that has CN and OH, which is the compound P. Look at this one, compound P. It has the OH and you have also CN. And I also interesting when I check this one, all right, this region. So let me just erase this one. I also pay attention on this region because the red one is basically is coming from the uh, hydrocarbon, usually coming from the hydrocarbon, but that really significant. And then you can actually check on your in your beta booklet on the thing that um, the structure. All right, so when I check this one, all right, so always this structure, it always coming from the OH, yeah, and then because the wave number is also quite large compared to the other, so definitely the contributions of the hydroxyl functional group is evidence. All right, now so I may deduce that this is actually compound P because we have absorption at 2250, all right, the wave number, and we also have the CN stretch, and then we also sorry, stretch, this here ST RETH, right? So, and then we also have a absorption at 3100 to 3700 Cm minus, and this one comes from the OH functional group. All right, so also the OH stretch. So I think that's all my explanation for this paper. I hope I have been helping you, and see you again in another video. Thank you and goodbye.